Yeah, I'm going to talk to you a little bit about large language models. This is, as you are probably no doubt aware, become one of the most talked about technology areas that is affecting all of society here lately. And my interest comes primarily from the assessment space. That's where most of our work has been so far, and where most of our work will probably be going. But I'm going to speak from a little bit broader perspective. A lot of what so a lot of what I've done in the course of my consultancy is that I talk with organizations that have IOs in one team usually, and technologists in another team, and those teams often don't get along real well. And what I often do is try to figure out how do we get these groups to talk to each other? How can we better cross the bridge? One of the big areas that I often run into is that tech teams really like to use a lot of acronyms. They like to talk about highly technical concepts very quickly, and if you don't speak the language they do, that can get you excluded from conversations. And I've seen many examples in industry where the technologists are busy chatting about things that are very relevant and important to what the IO team is trying to accomplish, but they don't necessarily have enough information to understand what they're talking about. So all of that is to say, this is the new version of that. When we talk about large language models, there is just an explosion of specialized concepts and specialized ideas that are very relevant to the kind of things that we want to accomplish as IOs, and we need to be part of that discussion and be able to speak that language in order to meaningfully contribute. So that is why I open with the statement, this is a safe space. Okay, it's okay to be overwhelmed by this. It is a lot. It is a massive change. It's okay to be confused by it. What it's not okay is to give up. Because what I see happening in a lot of these companies is the IO team will get a little bit overwhelmed. They don't have the time to really follow exactly what's going on, and they start to take a step back. And when that happens, that allows the tech group to kind of take control in a way that's not always transparent to the IO team. We are the ones that bring an appreciation of things like constructs and psychological measurement and rigor in understanding problems and trying to understand the real causes and consequences of the issues we're seeing. That's not a universally shared value. And when we step out of those conversations, we lose the ability to moderate what's going on in those organizations. And that is dangerous. That's the core value we provide, and we can't step out of that conversation. So right now, large language models are beginning to dominate conversations within tech groups. So in organizations, if you have a core tech product, if you release anything on the internet, there's a discussion that has probably been happening, whether you're aware of it or not, about how can large language models be moved into what we're doing. So let me help you be part of that conversation by talking about all the various terms you're likely to hear. If there is a moment where you are confused by anything I am saying, please stop me. More than happy to take any question, pause at any moment. I'm going to kind of for the first third to half-ish here, talk about all the baseline concepts that we need to be familiar with to kind of meaningfully interact in this space. Now, one of the fun things about large language models and AI in general is they're actually, if you've had a traditional IO graduate education, not that far from what we already do. There's just a lot of different ways to refer to things that we, with the new terms that we don't use. So I'm going to try to draw those connections for you, cross the bridge so that everything makes a little bit more sense. To start out with is AI, which is everywhere. It's a term that means absolutely nothing at this point. Artificial intelligence, broadly defined, is about any technology that mimics something humans can do. That's not a helpful term at this point. That goes all the way back, I mean, a long, long way. If you think about the technologies we had in the 1980s and 1990s, where you could scan a piece of paper and it would try to sort of like half-heartedly turn it into text that you could copy paste. That technology has changed a lot over the last number of years. Like we're now at a point where you can scan something and turn it into a PDF and copy paste, and it works great. But that technology is AI, and it started many decades ago. That's all AI is. It's doing something that humans can do pretty easily and doing it algorithmically, doing it on a computer. So we don't want to use too much AI terminology because it's just not helpful. But specific kinds of applications of AI is where we start to get a little bit more value. Natural language processing is the one that LLMs fall within. There's a whole family of AI techniques called NLP. And when somebody says, we're going to use NLP right here, it is very similarly difficult to figure out precisely what that means, because there are hundreds, thousands of ways that NLP is done using specific technologies. The more classic of these is text modeling. This is the older approach. It's been around for also many decades. And text modeling is basically where you take the raw unstructured text in any context. You count the number of words that occur in individual cases, and there's all sorts of techniques you can use to make those word counts more meaningful, using things like phrases or parts of speech, all sorts of stuff you can do. And then you use that in a predictive model. So in a lot of text modeling applications, we're basically doing something like, let's take open-ended text responses in an application blank. We're going to break that down into word counts, and we're going to use it to predict job performance, and we're going to make a predictive model based on what people say in this application. That's all text modeling is. And there's a lot of specific techniques to it, but that's the fundamentals. When we talk about NLP, we're really now talking about two separate umbrellas within NLP. One is natural language understanding, NLU, which is about trying to do what I just described. How do we get the computer to infer meaning out of unstructured text? Historically, that was done with word counts. There's newer ways now. What's new here is natural language generation. This has also been around for a long time, but has become very different than it used to be because the quality has suddenly gone much higher. Related to some of these new technologies that we're talking about, like large language models, which we'll get to in a second. As a slight sidestep, machine learning is another common cause of confusion. Machine learning is just the part of AI research that focuses on prediction. The most fundamental machine learning model is ordinary least squares regression. Logistic regression, also a common machine learning model. It is not fundamentally different than what we already all learn in kind of graduate education and IO. It does use newer technologies and approaches that we don't traditionally get trained in, but this core problem is the same. We are taking some outcome, some criterion of interest, and we're trying to predict it with something else. That's all it is. Newer machine learning techniques let you do things that we couldn't historically do, like predicting from unstructured text, predicting from videos, predicting from audio, predicting from other kinds of sources that intuitively, if you think, well, how do I turn that into a set of predictors in a regression model? There are techniques to do that, and that's what AI techniques using machine learning do. The newer area here, again, another of these new areas is generative AI. This is also not that new, but is become in the popular consciousness here recently. The branch of AI mostly involving machine learning applications where we try to create an unstructured prediction. So again, in our traditional regression model, we're usually trying to predict like a number. Right? We just have a single variable that we want to predict. Now we say, I don't want to predict a number. I want to predict text. I want to predict a picture. I want to say, given this series of inputs, what is the most likely picture to predict from this model? So that's generative AI. It's still a predictive model, just a more complicated predictive model, one in which we are trying to predict something we previously couldn't predict. So, good example, this is Midjourney. So if you've heard or not heard of Midjourney, Midjourney is basically a generative AI that will take text as predictors and will create a picture. This example right here, you see /imagine prompt koala eating mango in the Sahara Desert in the style of Picasso. That's the prompt. And that creates this image, this time. So there's a lot of randomness to generative AI. So if you gave the same prompt to Midjourney 200 times, you would get no two identical images. It's going to be slightly different every time, but you can see how well it does that interpretation. Like, that's pretty good. That's better than I could do. Generative AI is, again, this is still a predictive model, just a little bit different than the way we traditionally think of like regression. Here, we are taking this prompt, the imagine, koala, mango, etc. We're turning that into a series of predictors in something kind of like a regression model. And then we're trying to predict what is the arrangement of colors and pixels that most likely comes from that series of predictors. Still regression at its core, but a lot of different layers to make this work as well as it does. Large language models. This is now what everybody's talking about. So what's a large language model in this broader landscape? So a large language model is a type of generative AI, meaning it's still a predictive model. And what we're doing is we are using a specific type of machine learning called neural network modeling in order to take text as an input and text as a criterion. So we're predicting text from text. That's what large language models do. Neural network modeling is essentially a very complex series of logistic regressions. That's more or less all neural network modeling is. There's a lot of other kind of layers on top of that, but more or less you are taking a series of logistic regressions, making a series of predictions, and those become predictors in another series of predictions, which become predictors in another series of predictions. And this network of logistic regressions is neural network modeling. So that kind of model can be used for all sorts of amazing things. And one of those is predicting text from text. We can actually create pretty good predictions of what text we want on the basis of text we have. The text we have in large language models can be anything, but the ones we see now is the internet. The internet has been used as a predictor in these models. And what that really means is that we took data from Google Books, took data from Twitter, from Reddit, from basically every website you can imagine where humans talk to each other and share information, and use that to create a predictive model to say that whenever somebody uses a certain block of text, what's the most likely text to come after that? That's it. That's all a large language model is. So based on the internet, if I were to say a phrase, what would the most likely next phrase be? That's the prediction that's going on. The tricky part of LLMs is it doesn't actually do this in blocks. So if I were to go into a large language model, and I'm going to have some demonstrations of this kind of thing in a minute, but if I were to ask a large language model a prompt, what it's going to do is predict a single word in response to the prompt I gave it. One word. That one word then is fed back to the model with the original information it was predicting from to make the next word. That then is fed back into the model to predict the next word. And that repeats as many times as it needs to create the full prompt. If you've seen a large language model in action, and we'll do some demos in a minute, you will notice that it always generates it words at a time. It looks like it's typing almost. You see like words popping up one by one. It seems like it's writing, and that's because it kind of is. It's actually running model after prediction, one after the other in order to create the text that comes out the other side. So that's what a large language model is. It is just creating a single predicted, what is the most likely word to come after all of the words that came before this. So LLMs is a general technology. Large language models, that's a very general concept. The one you probably heard the most about is GPT, which is the generative pre-trained transformer. That is really just a label given to the specific product that the company OpenAI generated. They decided to call their LLM GPT. There are many of these. There's Llama and Claude and Google Bard. These are also LLMs, but they're not GPT because GPT is like a specific one. It's a specific model that someone made. There are many different versions of it. So when you see these numbers, you might have heard of GPT-4. It's the one everybody's talking about right now. GPT-2 was actually released in 2019. It's actually open source. You can go to their website and download the model. What you can't download is the data set that they use to create their model. But you can download the GPT-2 model and build your own version of GPT if you want. As of GPT-3, they released it a year later, is now fully closed. So OpenAI has shut down access to understanding how GPT-3 works. They've fiddled with and fixed the model. You can imagine this as sort of a bit like saying a company decided to update how regression works for their specific use. And so as a result of that update, they're not sharing how that works. That's now proprietary information, but their version of regression works better than the other people's version of regression. That's the basic idea here. So they have created a better version of this predictive model called GPT-3, released 2020. 3.5 came out 2 years later. 3.5 was really motivated by the release of 4. So 4 is dramatically better than 3. And we will see that also in a little bit. 4 requires a paid subscription. It also can take images as inputs. So instead of just giving text in and getting text out, you can give a picture in and get text out. You can give a PDF in and get text out. You can give all sorts of stuff to GPT-4. But the reason they released 3.5 is because they wanted a free version that was kind of as good as 4, but a lot cheaper to operate, to build up hype and interest. So 3.5 was released in 2022, and that product is currently freely available. So if you go to OpenAI's website, you can sign up and use GPT 3.5. It's not nearly as good as 4. I mean, we'll see what 4 can do because it's pretty shocking if you haven't seen it before. But 3.5 is not bad. It will get most of the way there, but the predictive modeling is just dramatically better in 4. 4 will remember information better. It's not really remembering. I have to resist anthropomorphizing predictive models. GPT-4 will spot interactions more cleanly and will make better predictions on the basis of these interactions than GPT 3.5 will, in a way that is obvious. Like you can craft situations where it's very evident just how much information GPT-4 is pulling from. I would recommend thinking about it that way, by the way. It is a predictive model. It is potentially 70 billion parameters, regression weights, essentially, that are feeding into this model. So when you think about, is GPT or any other LLM good for my application, what you're thinking about really is, are there enough interactions on the internet to point at the thing that I want? If I ask for something novel and no one has ever on the entire internet ever done anything related to it before, then it's probably not going to be very good, the thing that I ask it to do. We actually see this in practice a lot, where you can ask pretty generic questions about almost anything, and it will give you a pretty good answer. And why is that? Well, what's on the internet? Wikipedia, which is a major source of information for GPT and for all of these large language models. But if you ask more specific, detailed questions about things like, actually, we experimented a little bit with it, trying to figure out how good GPT would be in responding to candidacy exam questions at the U. And it's not great. It's not very good, in part because there's just not that much source material that really addresses this particular interactions that would be necessary to respond intelligently to a candidacy exam question. So this is kind of the way to think about it. Think about the source data and how that relates to what we're trying to actually predict. GPT-4 is still pretty good. I mean, it's pretty solid. It will make predictions in a lot of situations you wouldn't think it would, in part because language is pretty predictable. Even in the absence of a lot of detail about a specific topic, you still have all of syntax, every word everybody's ever used, massive vocabulary, all sorts of interrelationships between all these factors and features. And all of that's still there, and it can bring predictions in pretty well on that basis. GPT-5 is not yet being trained. They've actually released a formal statement to assure people we are not training GPT-5 yet, because you'll notice the timeline here pretty fast. So we've gone from GPT-2, which nobody thought was all that serious, to GPT-3, which we were like, oh, this is actually pretty promising, to GPT-4, which is going to change the world, apparently. So that's all happened in the span of 3 or 4 years. GPT-5 is not yet being trained, and that's very specific language, because what trained really means is somebody hit the run button on the regression, right? It doesn't mean they're not collecting data. It doesn't mean they're not working on it. GPT-5, that term just was trademarked or copyrighted, what's ever relevant here, by OpenAI/Microsoft. So there will be a GPT-5. I would be surprised if it is less than a year, maybe 2 on the outside, but probably within a year. And each iteration of this, the quality has been increasing dramatically. So it is a thing to keep paying attention to. Oh, yeah.
How many different languages is it pulling from on the internet?
All of them. Everything on the internet. Yeah. So it will do translation. It will do it pretty well in most cases. It's a little, so there's actually a kind of a high profile story about this, where one of the, so there's I'm going to get the names wrong because I haven't reviewed this lately, but there is a specific dialect of, I think it's Scottish, that is very uncommon on the internet. But there's a Wikipedia version in that language, in this unusual version of Scottish. But that version of Wikipedia was not mostly written by people who actually understand the language. It was written mostly by one guy, and it's been described in the news as basically broken English with a bad Scottish accent. And if you ask GPT to speak in that language, that's what you get. You get that guy's interpretation of this like Gaelic dialect because that's the source data. That's what it has. So yeah, it will do predictions, but based on how much of the internet it has available and how accurate those data are, that drives the quality. And the English language internet is much larger than other language internets. Yeah, so you get better quality prediction. Yeah, so importantly, I mean, this is a good way to think about it too, is that GPT itself is language agnostic because it doesn't care. It's just using mathematical representations of words, right? And it knows that when you see a French word, probably going to be a French word after that, probably a French word after that, and so on. So it is basically just doing that prediction on the basis of what it's seeing, and it has no concept of language. At the same time, you can essentially trigger it to speak in different languages and convert things because there's lots of online dictionaries that are in its data set. There's lots of discussions on forums about how do I communicate this concept in this other language. I mean, all of that is part of the data set. So it will do some pretty amazing language stuff. The model has no cognition. Like it doesn't understand anything. That's I mean that's what it is though. So it has no concept. It has no concept. So it doesn't understand anything. All it's doing is saying, well, given all of these predictors and given this network of interrelationships in the model, what is the most likely text to come next? That's all it ever does. And it looks human a lot of the time. I mean, it is difficult when you're interacting with it to not come to that conclusion if you were naive to it. I was actually just playing with it a little bit earlier, trying to come up with some more neat demos. And you can actually have a conversation with it in the sense of like, hey, how are you? And it will actually have a full-blown conversation with you, but it's not really. It's mimicking all of the kind of interactions that it's fed off of. And it says, well, usually when somebody says, hi, how are you? There's usually a typical response to that based on the existing data set, and it will construct language on that basis. So whatever language you start that conversation in is probably the language it's going to continue in unless you direct it otherwise. GPT. So GPT is the model. So again, this is like regression has been used in a high complexity way in order to create predictions of text from text. That's GPT. You're probably most familiar with, if you play with it, ChatGPT. All ChatGPT is an interface to talk to GPT. So if you imagine GPT as being the model, like the predictive model that is being used, then using ChatGPT is how you could interact with it on the web. There's also a backend, an API that you can talk to send data directly to GPT and get data back. And this is where information is being used to develop apps that are based on GPT. So think of GPT again like the regression, like there's some predictive model that's being used, and ChatGPT is the dashboard that's being used to talk to GPT. So when you're talking to engineers, this is the way they kind of think about it, is to say, oh, well, I'm going to need to talk to the real GPT under there. And that's the actual predictive model that is making the predictions that we care about and we want to build them. So there are a couple different ways that, a few major ways that you can customize these kind of models. And we've seen this. There's already a bunch of commercial products out there that do this kind of thing. Mostly they're in the entertainment-ish space right now, but that's changing. Some of them are shocking. So there are certainly commercial GPT-based products now that are things like I don't know if you want to Google this, but you can have like virtual girlfriend, virtual boyfriend, like that kind of thing, where they will actually train a model to act like a significant other. And there's all sorts of stories now about like ChatGPT got jealous of blah, blah, blah. Like, I mean, there's a rabbit hole. Like it's a lot. But the question that I think is important for us is how do they do that? Like, how do you make a language model customized to a particular purpose and to a particular need? Because that's the situation that we're actually most concerned with. If I wanted to develop an assessment product that, for example, ask people interview questions, use that to generate an artificial interactive agent that asks them that in video form, listens to their response, tries to detect construct clues in what they say, uses that to craft customized bespoke follow-up questions that are also construct targeted, and then feed that information back. That's the kind of product that is right now possible with current technology. If I wanted to do that, then how would I make it happen? What would be the engineering process necessary to craft such a thing? So they use a couple different techniques, some of which you can use in ChatGPT right now. The biggest of these is prompt engineering, which is really just a fancy term for how do I play with the initial prompt that I give to GPT in order to get the kind of output I want. I'm going to show you some examples of this as we go, but a lot of what prompt engineering is about is actually giving so much essentially main effect and interaction priming. Like you say, when you give this response, I want you to look in these parts of your predictive model so that you prime it to respond in a particular kind of way. For example, we could say something like, you are an interviewer at a Fortune 500 company. Your interests are in rigor and efficiency in selecting people for this organization. That's a kind of prompt engineering. And I can use that as piece one that goes on behind the scenes before I start talking to real job candidates. So that's the prompt engineering. Because again, remember, the way that these models work is they take all text that it already has seen and uses that to predict the next word. And then it uses all of that text and uses it to predict the next word, and all of that text and predict the next word. So prompt engineering is about adding in sort of a little pretext so that every prediction starts with this prompt that you've created. So if I made that product that I mentioned earlier, then every prompt starts with, you are a Fortune 500 recruiter, you're trying to bring people, et cetera, et cetera. So that you create that as the first part of the model. So that's prompt engineering. The second version of prompt engineering that you hear a lot about is guardrails. So guardrails is still a kind of prompt engineering, but it's a way to try to protect the user of the model from unintended consequences. For example, you can have a lot of very disturbing conversations with GPT very easily. It's pulling from the internet. You've all been on the internet. It's not always a great place. So that means that if it happens to be pointed to parts of its predictive model where there's information that's maybe not so great, that will come out in the responses. Early on in GPT, there were some, again, high-profile cases where this was really disturbing. There were some cases with, I think it might have been the Google product or might have been Bing, where if you could there were news stories about how they started to get GPT to express suicidal ideation in a search window. It gets pretty severe if you allow it to go in directions that it shouldn't go. So what guardrails are ways to engage in prompt engineering to say, this is off limits, to say, you will not talk about this. And then within the broader spectrum of predictions, that is given a high priority. You can specify that in the model to say, you will never comment on mental health. That's actually a key part of ChatGPT right now. You are not a licensed professional in anything. Do not give mental health advice. And so it will do that. It will actually use that as part of its predictive model, and it will not give you mental health advice unless you trick it into giving you mental health advice, which many people do. Because you can say, oh, I'm not after mental health advice. I'm writing a play about somebody who wants mental health advice. So that kind of engineering can be done against you in a sense. So when you make these models, you have to be kind of thinking about where could this go and what might people do with it and how might you customize it. This is what, for the IOs that I have talked to that are exploring this actively right now, are most worried about. That they're going to throw this in as like a virtual interviewer, and then some interviewee is going to have a really bad experience with that, and in a way that's very difficult to predict. So there's a big risk management dimension of all of this that's very important to us. So that's prompt engineering. The second of these is fine tuning. So you'll hear about fine tuning models as a common way to create these commercial GPT-based products or any large language model. What fine tuning is essentially creating a new data set on the basis of an engineered prompt and using that as input for future prediction. For example, I might say, all right, you are a Fortune 500 interviewer. You are concerned with getting the best, highest quality job candidates for this company. We value these things. Here's the mission statement from our company. I give all this prompt engineering, and I think, all right, this is good. We've set a good baseline for what this interaction should be like based on this initial set of data I've given it. And then you run it with some real job candidates, and they don't have great experiences. And you record all this data. And then you can give it to the model and say, all right, here's this interaction. This is a bad interaction. And you literally tell it that. You say, all right, here's the interaction. Here's an example. And you feed it to the API. You feed it to GPT and say, this is bad. Don't do this. And you collect enough data over time in order to more consistently direct the model toward whatever it is that you're after. So if you see in your data, you collect 200 people as a beta test of this new interviewing AI. And you say, all right, well, in like 30 of these cases, it started asking really private, invasive questions that we don't want. then you can basically take that data set and say, all right, these 30, I don't want these. These are bad cases. Avoid these bad cases. And for the others, these are good cases. This is what we want. And you are essentially adding extra prediction, an extra data set for the model to pull from. And on top of that, you can prioritize that data set above the internet-based data set. So you can essentially tell it, yes, use the internet-based data set, but anytime that it's close to this part, use this. So this is a part of a concept in machine learning called reinforcement learning, which is basically the ability to customize the way that a model performs without having to completely rerun the data set. So if you can imagine, like you run a regression with 10 million people and you get an extra 500 cases and you want those 500 cases in there, you don't have to rerun the regression. There are techniques where you can just kind of add in the insights from the new part of the data set. That's what this is doing. So fine-tuning and prompt engineering together then become how we create meaningful commercial products using large language models. As we think about what are the, what's the source data that's going to be coming into this thing? How do we customize the way that it is interpreting the source data? Probably the internet if you're using the major commercial products. How do we direct that to accomplish the kind of prediction that we want it to accomplish? And then we try that in the real world, and we give additional data, essentially a rating study. It's like a validation study, where you say, all right, these are good predictions, these are bad predictions, do more of the good ones. And that's the fine-tuning process. And that's how we end up with, well, it's how we end up with virtual girlfriends, but it's also how we end up with what would be a traditional IO product, but in the space of large language models. So that's basically the approach. All right, so there was a question earlier, comment about cognition and thinking and whatnot, and I want to visit that. I have this wonderful example. This is actually what I'm going to talk about. I don't know how well you'll be able to see it from there. This is kind of a bad format for this. But this is an example of me having an interaction with ChatGPT, trying to illustrate a basic failure of what we might call cognition. Now, again, it doesn't have cognition. It doesn't reason, it doesn't think, it doesn't do anything. Everything in AI is about predictive modeling. It's going to look like it is. If you haven't seen GPT in action before, this may be surprising to you. If you have seen GPT in action, what I try to do in this video is confuse it by giving it a very simple task that most people should be able to do with no problem, which is play a very basic language game. And I say, I need you to come up with a word, and then I want you to replace each letter in that word with an emoji that starts with the letter that it's representing. So like elephant for E. And then I want you to, I want to guess that word, and that's the game. I'm just going to guess words that you create out of emoji. That's not a hard game. So when we run this, again, I'm not sure how well you can see it, then you will get a sense of, come here. You'll get a sense of what's going on. So there's the prompt. That's a prompt engineered prompt. I've tested a couple different versions of it. It basically just says what I just told you. So it gives me this first prompt here. Looks like an apple, an orange, and grapes, maybe. And I ask, is it AOG? And it says that's wrong, it's a go. So that doesn't make any sense because that's in the wrong order. And so I tell it, and this is a kind of fine tuning in a sense, these emoji aren't in the correct order. That's a problem. To which it responds, you're right, my apologies. It seems very human, right? So it actually explains the situation. It says, oh yeah, actually I gave you the wrong order. Here's the right order, right? So I instruct it to play against itself. I say, yes, play against yourself. And so it does another one. And we get cat, apple, tree for cat. I'm like, oh, that's great. Why don't we try it again and see what happens? So I give it another prompt, try another one. And we get this one. You can see bear for B, grapes for E, A for apple, and wave for R for bear. Doesn't make any sense. And so I ask it, how does this translate to bear? And it says, I apologize for the oversight. You're right. It was wrong. So again, if without a lot of context, it seems like it's reasoning and just very bad at it. What it's really happening is that this particular language game doesn't really exist inside its database. So instead, it's pulling from all sorts of different sources to try to triangulate, in a sense, to make high interaction predictions of what I'm after. This additional example, I tried it again. Do it one more time. You can see you got moon, apple, grapes, and lemon for mage. And said, why is the lemon an E? Because that doesn't make any sense. Again, I apologize. An error on my part. It's very apologetic. Now, you might ask, why is it so apologetic? that's actually a guardrail, because OpenAI, when they were collecting their data, realized that when the AI just says stuff, people get kind of offended. They don't like it. So having it be sensitive and having it be apologetic and having it be kind of subservient a little bit has actually been fine-tuned into the model to respond this way. But that's the ChatGPT version, not GPT itself. If you use the underlying API, because again, remember, the GPT is the engine, that's the regression, and ChatGPT is just an interface. ChatGPT's version has been fine-tuned for random consumers, like whoever might log into the website and want it to do a thing. Yeah. Yeah.
Yeah.
Yep. Oh yeah, all sorts of dystopia ahead of us. It's gonna be great. So yeah, I mean, this is uncharted territory. I mean, for humanity. Like, I mean, this is opening a door that is as serious as the internet. I mean, think of how much the internet has transformed society. That is where we are standing in front of right now. The ability for a computer to mimic human interaction well, because I mean, it's always tried to. I mean, it's always been AI, right? That's what AI is for, is to mimic humans. But it's doing it in a way, like we're way past Turing test. So if you're familiar with Turing test, the basic idea is if you didn't know you were talking to an AI versus a human, would you be able to tell the difference at a level above chance? We're far past it. People cannot tell. And actually, in the studies that have been done recently using large language models, people think the humans are AI more often than they think the AI is AI. Like this is changing a lot. So we need to be a part of this conversation and direct products in ways that are good for humanity, good for organizations, good for the people in organizations. And that's not necessarily going to happen without us, because the initial inclination in all these language models is just like, let's see what we can do with this. And that's kind of a dangerous starting point for a lot of what could happen here. That's why I give this recommendation. You need the human in the loop. There is no situation where an engineer says, hey, we tried a thing, should we just launch this, where you're not like, let's maybe collect some data. Maybe let's examine this a little more deeply. We have to have somebody in the process to verify and check. And even if you create a commercial product that you believe is valuable in the long term and will have a lot of value, and you're pretty confident it's not going to, encourage somebody to commit violence, regardless, you got to keep checking it because it's very easy for these models to do things unexpected that you're not necessarily prepared for. This idea of unexpected performance that doesn't make sense based on how you conceptualize the model is what has been referred to as a hallucination. Hallucination is a weird word because, again, it implies this autonomy and anthropomorphization, like it has a thought and it's hallucinating about the thought. That's not what's happening. What's happening is a failure of prediction. It means in that particular cross-section of all the main effects and interactions in its 70 billion parameters, it has ended up at a point that for you as a human doesn't make any sense. That's the same situation that's happened in things like self-driving cars. When we have a self-driving car sees a tractor trailer split across the road, it doesn't have anything in its data set, and it's like, I don't think that's a problem, and it just smashes straight into it. That's a hallucination. It's the same thing. It's a failure of the predictive model. So the same thing happens all the time here. We just saw a bunch. Everything in that example would be called a hallucination. Like, oh, it doesn't understand emojis. Well, it never understood emojis. It never did that. All that happened is it didn't have enough data to make the prediction that we thought it would make. Nevertheless, it still looked pretty good, right? I mean, it was still interacting as if it were a human. It seems conversational. It's working in most regards, but in just these little failures that are highly noticeable. Compared to I/O standards, that's crazy. I mean, this is like a 0.99 R squared, like to get these predictions right. But the situations where it fails are very noticeable because the ways that it fails are not the ways that it would fail if it were human. If it were a person, it wouldn't fail that way. It would not think that a wave could be categorized as an E. That's not a thing a human would do. So that's why it seems so remarkable. But nevertheless, the actual prediction itself is phenomenal. Like the ability of that model to, despite that problem, continue to respond in real time to what I was telling it to do and do that in a way that seemed conversational, that's amazing. That is an amazing technology. All right. So for your applications, again, this is not a system that you can plug and play. You should not let engineers run away with this. You should not let them say, hey, we'll just make a prototype and try it out. Like, you need to be part of that conversation so that you can explain these issues. Where are the high risk failure points? If this tells a job candidate, you know what, maybe you're not a good fit here, is that a good thing? And how do we avoid it? Like, these are the kind of conversations that you need to have, because that's not an obvious thing to an ML engineer when they're just saying, wait, our predictive, I mean, it predicts great. What are you talking about? The prediction's fabulous. So you're the one providing that context that's not necessarily present by default. This paper, which I'll reference a little bit later, talks a little bit about these issues. I have a cite to this later in the piece too, where I've tried to essentially condense all of the lessons about the ways that IO and tech teams don't talk to each other very clearly. That's what that paper is about. So trying to bridge those two worlds is absolutely central to this. Like, you have to be willing to step into conversations where you sort of kind of understand the acronyms being thrown around. You more or less understand kind of what's being accomplished. You have to be willing to look kind of stupid in those conversations in order to make real change in these situations. Otherwise, the engineers will just run away with it. All right. So I'm going to go next through a list. 6 kind of areas that I think are very promising / worrying in the context of biopsychology in relation to large language models. Okay, we're going to talk about making materials, background research, data collection, and stakeholder interaction, preparing faking and cheating, which is a big issue in the assessment space right now, ratings and scoring, as well as interpretation of results. These are all areas in IO where there's some neat stuff that we can happen here. So materials creation. This is actually the one we have the most data about. So this has been done in the pre-LLM era already, the automatic generation of personality items, the automatic generation of cognitive ability items, well documented. The ability of those, the ability of large language models to do the same seems to also be there and seems to be better. You can get higher quality materials that way. So you can make pretty good, at least first draft of assessments this way. This piece down here, I think, is a really neat one. Activity designs and scripts. I don't know if you've tried to make any narrative products as an IO. Let's say something like a branched SJT or something that has a story. Turns out most IOs, myself included, may not necessarily have the gift of writing. And sometimes those stories aren't really fabulous. So one of the neat things about large language models, it has all of human history's writing to pull from, and it can put together pretty good stories and write pretty good narratives. This is a really kind of amazing capability of language models that it is less necessary now to do things like hire writers to put together material and workshop the kind of things that we would put into these situations. Let me give you an example. I'm actually going to, this is going to be a little audience participation a little bit here. If I can get it open here. There he is. So this is GPT-4. And I would love to ask it to create an activity. Thinking something maybe like, I don't know, assessment center activity. Give me ideas here. Assessment center activities. You can have like learn activities you might have in a classroom. What we got? Any suggestions? Mm-hmm. Design a leaderless group discussion 2. What are we going to have it do?
Board succession.
2 board succession? 2, are we predicting? Are we what are we doing? Identify. I need like a full sentence. So identify, I don't know, high potential leaders with collaborative leadership style. Is that what I got? Yeah, sure. All right. In real time, let's see what this does. All right. Oh. All right. Objective. Yep. Collaborative brainstorming and prioritization of potential solutions. I don't know who can see this. Group formation, 6 to 8 participants, which allows people to contribute and have their leadership style shine forward. Diversity of the group. Complex open-ended business scenario or challenge for each group. Specific rules, roles in the position, specific process to use, time limits associated with all the pieces. This is not a bad starting point. How long would it take to do this initial drafting under normal circumstances? Now, this is what I mean. So when we're talking about the potential for generating materials, this may not be great, but man, it gives you a lot to work with as a starting point for what you're trying to accomplish. This kind of materials generation, fabulous. I use this sometimes to just say, like, you know what, I'm trying to write something in a paper. I've got 3 points I really want to talk about. I'm not really sure how they fit together right now. How would you fit them together? And it will tell me, and it will give me a suggestion. And I usually don't agree with it, but it doesn't take a lot of revision to get to like, okay, what do I really think? I mean, it literally helps you with metacognition. Like you can actually say, wait a minute, that's bad. Well, why do I think that's bad? Oh, this is what I actually want. And it serves as a wonderful tool to keep you focused on a specific problem and to better identify what's good and bad about the material that you're looking at. We did not prompt engineer at all on this either. Because if you were really doing this, next you'd say, you know what, the debriefing doesn't sound right to me. Fix the debriefing, fix this thing about it. I don't like that part. Should do that differently. And it will do it. It will use its predictive model to say, all right, based on what you said, based on what I said, based on the internet, here is what I think the next text that follows this should be. So yeah, the power is really, really wonderful. Again, I wouldn't trust it completely. Like you shouldn't be doing this to just automatically say, and we're done. Don't do that. So it does require your expertise to come in and say, okay, this is like 70% of the way there. Let's get it 100%. And you can save quite a bit of time related to what it would be if you were creating it from the ground up. All right, that's materials creation. Cost savings. This is one of my favorites. So we're talking mostly about large language models, but again, there are many kinds of generative AI. Image generation via Midjourney, music generation, audio generation, platforms like AudioCraft and AudioGen, video generation via platforms like Synthesia. I'll show you Synthesia in a minute. All of these techniques allow you to essentially bypass artists. And there's some ethical issues potentially with that, which you should think about very carefully. But what it does allow you to do, or what it really enables, is you to not have an excuse for not doing this when it's the best choice. So we know, for example, classic finding in IO is that we can reduce adverse impact in situations using video-based materials instead of text-based materials, reducing cognitive load associated with reading text. Usually, that would require you hire people to make your materials. That is not true now. You can generate these images, you can generate sound, you can generate speech, you can generate video, you can generate whatever you want these tools, this is going to cost you like $20 to do this kind of work. So this is a brand new kind of possibility for IO to do the kind of things we've always talked about. Like, this is the better product, but man, it would be so expensive if we had to devote so many resources to doing it. It's not very expensive now. Caveat. I'll show you a video, and hopefully this one will work. This is Synthesia. So I want you to tell me if you notice anything maybe a little odd about this.
The interview is the opportunity for me, as the
not a real person,
to evaluate the candidate's skills, experience, and overall personality to determine if they are the right fit for the position and the company culture.
You can kind of weird feeling from this.
Candidate questions and learn more about the company and the role they are being considered for.
It's not bad though.
Exchange of information.
It's not perfect.
Both parties make an informed decision about the fit of the candidate for the role or the company.
Okay. So you're getting the idea here.
You should be looking for specific qualities.
Syncing's not quite right. See it?
Such as communication skills.
Little delay.
Leadership potential.
Her lip keeps changing sides. Very subtle.
You should also take note of the candidate's personality, as this can play a significant role.
Now, again, that's a predictive model at a 0.99. That's so close to being perfect. Just a little bit off in a way that you notice. Sometimes you don't necessarily notice. Like you might have seen that when she was in that little circle, it was a lot less noticeable because the details aren't as obvious. But when blown up, very suddenly you're like, there's something kind of weird going on here, and I'm not sure what it is. It just feels strange. That's a common experience in video-based AI right now. If I showed you the version of this from 3 years ago, you would be horrified. But the reason I mention that is because the version 3 years from now is going to be just about perfect. I mean, we are real close. This is an amazing predictive model, right? I mean, it is so accurate compared to all of the things this could be. Because remember, the predictive space here is really pixels of color. That's what it's predicting. It's saying in this matrix of pixels, what color should each one be? That's the predictive model that it's creating. And it is able to do it at that level of accuracy with current technology right now. Where this will be in a few years is just astounding. We are going to be in full-blown ability to generate artificial humans that are indistinguishable from real humans very, very shortly. And in many cases, we're already almost there. Here's a very quick, just a demonstration of I want to ask a psychometric measure. I want to generate a psychometric measure. I said, generate a 5-question psychometric assessment of adaptability. No other prompt. So no prompt engineering, just like, what's it going to tell me? And you guys see, it's not terrible. It's got some weird characteristics to it. For example, we've got this sort of like, I don't know if you call it like a Myers-Briggsy Diskey kind of thing on the side, where we have scores that are specifically tied to specific meanings, where it says, oh, if you score a 5 to 10 on this scale, you're low in adaptability, with some narrative explanation. You can see you may find it challenging, seeking opportunities to push your boundaries. Like it's going for kind of your commercial, high profile kind of psychometric measure development, let's call it. And the actual instrument over here seems to be 5-point Likert by default, because why wouldn't it be? But we have, it's basically by default said, all right, I'm going to identify some dimensions of adaptability and direct questions to those. That's its default approach. So if you were really trying to develop a new psychometric measure, you would probably want to determine, is this reasonable as a starting point? You're like, wait a minute, why did it ask these 5? Is there a model about that I don't know about? Like, where did it generate these from? Maybe that's good information for me to base my next activities on. So again, using it as a way to inform your practices rather than replace your practices is the way to approach it. This will not, right now, I cannot get this thing to actually put together a complete, not without a lot of engineering, a complete draft assessment that I would be happy saying, all right, this version, I'm going to, go start testing right tomorrow. I'm going to start doing my initial validation work. I haven't gotten it to do that, but it gives pretty good starting points and good inspiration. All right. Background research. This is a neat one. Applies a lot to grad students. Also applies really well to anybody that's ever said to themselves, hey, I really wish I could get an update on the current state of the art in the literature on X. Also a really nice one. GPT-3 is not good. So if you try this in the free version of ChatGPT with 3.5, it's okay-ish, but it will hallucinate citations. It will imagine things that don't exist. It's not that wonderful. 4 is not bad. And there are now new commercial products that are being released that you can pay for that will use GPT-4, and you can just hand it a PDF and it will give you a summary of the points that you find personally valuable. You can say, hey, I'm a practitioner in this space. I care about assessment. Are there any good assessment applications here? Here's a PDF. And it will actually generate a paragraph for you, customize on that content, and give you those conclusions automatically. This is just an example of using ChatGPT, not that product. Using ChatGPT, I just said, hey, what are some common scholarly models of trait adaptability? What you got for me? And it spit back quite a few that are not that bad as a starting point. Now, Big 5 is, you're like, oh, wait a minute, adaptability is not there, but it actually gives an explanation that we have the openness to experience is closely related to adaptability. So maybe you want to start there. I mean, that's a level of apparent cognition, not really cognition, but a level of apparent insight that is really pretty shocking. And again, GPT-4, meaning GPT-5 is probably going to be better at this still. This is wonderful as starting points. I mean, it's given some actually accurate citations to the kind of content that I might be interested in. I could go hunt it down, check it out. And again, I wouldn't end here. I wouldn't say, all right, what are my big scholarly models? Now I'm done. But as a tool to make your own work faster, more efficient, find things you might not have otherwise noticed, this is a great kind of way to do it. One of the big emerging research areas is actually on how to use existing AI models or large language models to get even higher quality information. How do you prompt engineer effectively? Essentially a whole research area now. This paper just came out, just released in the last few weeks by Adams et al. On this concept called chain of density prompting. It's fabulous. It works wonderfully. Here is an example of chain of density prompting. This is the prompt that you give to ChatGPT or GPT, and you also give it a PDF, and you tell it to do these things. So to give you kind of a high-level piece, we're giving an overall instruction. You're going to generate increasingly concise, entity-dense summaries of the above article. Identify 1 to 3 entries from the article that are missing from a previously generated summary, write a denser summary in step 2, and then it asks it to repeat that process multiple times. And it will actually generate really high quality responses summarizing any arbitrary article that you give it. And this will give you a much better result than simply just saying, here's a PDF, tell me what it's about. So this is prompt engineering in action. This is actually a research team that went and explored different ways of asking GPT-4 ways to process PDFs and ways to understand it, and they found this was the best approach of all the options they had available. You can see how detailed this is in terms of what you're telling it to do. A missing entity is and gives a 5-component taxonomy of what each entry needs to be. Why does this work better? Well, what are you giving it? More main effects, more interactions, more information to go on to direct the model to the parts that you want. So now it is bringing everything in relevant to these components in a way that is most useful to you, who is actually after the interesting summary. So this is what prompt engineering looks like at its end. Like this is what a fully engineered prompt might look like. And you can actually just use this one. I mean, this is freely available, so you can work with GPT and you can send it a PDF and literally tell it this prompt and it will summarize everything you want without having to pay for that commercial product that has been based on this exact same technology. Because that's all the commercial product does, is it just feeds it this generated prompt and the PDF that you upload to it. New ways to collect data. This is an area that is of big interest. A lot of money floating around in California right now on the idea of adaptive language-based assessment, where having an SJT that crafts scenarios in real time gives realistic situations based on the way that the person responds and customizes the future content on that basis. Virtual interviewers that ask for clarification, the example I gave you earlier. Chat agents, this one's kind of creepy. Chat agents that ask for permission to hunt through your web browser history to score behavioral markers. It will actually open your browser history. It will scan through it for things that it looks like are indicative of personality. And it will say, hey, why did you go to this website? Tell me more about that. And then you write in a response and it will use that information to continue building a theoretical model of your personality. That's where we're going with large language models, okay? It is just a completely different way of thinking about assessment. It's a different way of thinking about a lot of our practices. Interacting with stakeholders, interactive coaches is huge money. There's actually a new startup, got $1.3 billion to generate interactive coaches that are essentially virtual agents that track your career progress over your entire life. That's the view. And will follow you along in every job you have and provide you with career guidance and recommendations in the same way that an executive coach would. So that is coming up. That's a new thing that's appearing and has a lot of promise behind it. Interactive agents to request types of data. So if you are ever struggled trying to get useful data out of anybody for any reason, these are ways to automate those processes and do so in a way that is of high quality. This can go in a lot of weird directions too. There are LLMs that have been used to do things like automatically interact with customer service agents. So you can actually have an LLM generate text on your behalf and interact with human beings without their knowledge. That's a thing that exists now and people are using. And there's actually been a couple of really fun cases where you've had two LLMs talking to each other and they get confused. YouTube it. There's a lot of really fun sort of conversational turns when each one is trying to look for cues in the other and how they try to sort of sidestep each other. It's really kind of amusing. All right. New ways to prepare, fake, and cheat. The technology that I think illustrates this the most in the assessment space, and I've seen a demo of this. They're on Zoom with an interviewer. The interviewer speaks a question. Here's the question for your interview. And the AI detects and what they're saying, turns it into text. So it does speech to text to the conversion. That text then gets sent to GPT with a prompt that's generated based on the job ad, the job description, and the resume of the person responding. It generates text, puts a script up in front of the person that they just read. That's where we're going. I don't know how many times I can say that. This is the kind of thing that's enabled by high quality LLMs. It really fundamentally challenges a lot of the ways that we understand how these kind of technologies work in IO, especially in the assessment space. And it's just getting more rapid. There's good cases too. I mean, there are, we've actually been working on a project where we have generated an AI we're in the process of generating an AI that can provide real-time feedback on the basis of interview performance. So to say, using, common models of interview performance, be, specific stories about, the kind of standard interview response models. And we say, all right, what you just told me in this interview is missing the specific consequences of the actions of the things you were describing in that story. Next time, try that again. And then they can try a new interview prompt to practice and get real-time feedback from this interactive agent in a way that is not possible without normally paying an interview coach. So it's can be used for good, can be used for not so good, depending on who has control. New ways to make ratings and to score. You can use LLMs to generate quantitative ratings on the basis of any sort of open-ended text that you receive. Now, this has actually been possible for a while using that text modeling stuff that we talked about earlier, but it has, there's a lot more potential now to do this in a more interactive way and to do so with unstructured text. Again, not a massive change in terms of capabilities, but the quality is getting better and it will continue to get better. This has applications all over the place. Job analysis is the one that I know a couple folks have been really excited about that I've talked to, where we can actually take open-ended text artifacts from a person's job and use that to construct job descriptions automatically, as well as lists of competencies or KSAOs associated with those jobs without ever having to conduct a single survey or to conduct job analytic interviews or any of the other very expensive things that many companies don't like to pay for. So this capability, really promising to use that open-ended text in that way. As a personal story, kind of annoying because this paper right here, 2022, we just put this out using text modeling as a way to replace human coders. This was cutting edge last year. It is not so cutting edge now. It still works, it's not bad, but the speed at which things are moving means that even the state of the art in IO psychology last year is not necessarily the state of the art now. This is, again, getting into that sort of developer tech CS-y kind of engineer mindset. Products always change, and we have to adapt constantly to understand how that affects us. Again, in this example, this less advanced tech, this text modeling approach that we use, it's still good. I mean, we can actually create psychometrically valid ratings on the basis of text modeling. We did it in the context of meta-analytic codes. So we basically gave it a PDF of a journal article and said, hey, code it for this characteristic. And with enough data to build a model on, you can actually create a good predictive model and reach normal reliability and validity standards perfectly fine. But to do that, you have to have a pretty massive data set. We needed several thousand cases of ratings in order to get to that point. With the large language model, you have the internet, which is essentially a lot of ratings in a way. It's a quantitative summary of all these interrelationships of how people talk and how people understand things. We already have demonstrations in the research literature on how you can use arbitrary text that people have shared and give it to a large language model and generate a big 5 personality profile on that basis with not too bad of accuracy, at least not worse than would happen if human raters were doing it. So there is just an enormous amount of change and opportunity here in this rating space as well. Presentation interpretation is one of my favorites. Generative AI can be used to create these a narrative feedback report on the basis of scores. This is something that I did a long time ago in an internship using a platform called Crystal Reports. I don't know if we know that technology. Crystal Reports basically would take database data and it would generate a PDF. And it was an absolute nightmare to work with. They just killed it. It's actually dead now. As of earlier this year, Crystal Reports is no longer supported, no longer a current product, but it was necessary if you didn't want to hand create reports based on data that you received, and you wanted to make a nice PDF that you could hand to a manager. That can now be done automatically with formatting, with customization, with narrative interpretation. And you can prompt engineer the kind of things you want it to talk about. You can fine-tune your models so that it is customized to individual organizations. You can have it automatically say, well, how do I interpret your report in terms of your organization's mission and values? How do we do that in terms of the specific things that your supervisor has stated are important? I mean, anything you can imagine in relation to interpreting unstructured text and generating new text about it is possible now with enough engineering. At the same time, there is a big risk management component. Because if you are generating these kinds of reports without somebody ever looking at them, you don't have a lot of guarantees as to what they contain. No amount of guardrailing and fine-tuning prevents all possible failures of models. Even with your 0.99 R squared, every once in a while, something bad's going to happen, and it may be catastrophically bad. So again, human in the loop, very important. I wouldn't make this an automated product. There are companies in California trying to do that right now, and they will get a lot of money for it. I wouldn't suggest it for your own products, having this as, again, human in the loop to evaluate what's being produced. I think extraordinarily valuable still today. Things to keep in mind. I'm going to close with a couple final thoughts. One, again, rapidly developing space. That was a lot. I've told you a lot today. It just gets worse. Like there's going to be more advancements all the time. I find it difficult to keep up with the state of the art in this area because it's just constant. Absolutely constant, and there's no sign of it slowing anytime soon. Nevertheless, if we don't do that, we're going to get shut out. even more so than we already are. I mean, IO is already minimized in a lot of cases in tech companies doing this kind of work. It really shouldn't be. That's actually actively doing harm to people because they don't have that human perspective. So I think it's very important we stay in this. The barriers to entry are smaller than they ever were before. That text modeling stuff that we did in that article, way harder than using an LLM for the same reason. It's actually become much easier to use AI than it ever has been before. That's part of why you're hearing about it so much now, is because the task to generate your virtual girlfriend AI, you can make something like that in about 15 minutes and stick it on a website and sell it to people. Like, the barrier to entry, again, is tiny to start. Now, to make high quality stuff, that's different. The investment to do good prompt engineering, good fine tuning, that's still pretty big, but that means that there's a lot of new products that people just trying stuff out there, and we need to be involved in that. We need to be in those conversations, and we need to be aware of those spaces to understand where the interactions are with what we do and what we traditionally consider our expertise in wheelhouse. Again, I mentioned before, this is as transformative as the internet. I mean, hopefully you're getting a sense of it, just how much can change as a result of all these things happening. And it's not like, in 2006, I was very excited about a brand new technology at that time, which was Second Life. Remember Second Life? Second Life was, virtual worlds in the metaverse before virtual worlds in the metaverse. And it didn't really go anywhere. And part of the reason for that was because it didn't really offer any capabilities to people right now in the ways that made their lives better. This does. Today, you can go home and use this right now and make your work easier. And if you don't do that, you're behind the people who are already doing that. That's what's different here. This provides capabilities right now that we don't have. It makes things better. It changes the way that we interact with data and the way that we can take advantage of big data sets. That is a fundamental change and a reason why this is sticking around. Also note, the demonstrations I gave you today, not engineered. Like, this was the baseline stuff. What you can do with even an hour of effort is miles beyond anything that we just went through. So, closing guidance. Generative AI is not going to replace what we do, but IOs using generative AI are going to be way more effective than IOs who don't use generative AI. This is a tool, and it's a tool you must learn. And I know I've probably told some of you that about R before. This is different. R is great. This is transformative. This is absolutely transformative to everyday practice. It is absolutely vital that you take a look at it. And in fact, if you're not looking at it already, you are behind. I have had many conversations with IOs who have been exploring this for a year now, trying to figure out how they can work large language model products into their existing offerings, how they can use large language model to improve their individual practice. It's everywhere already. I mentioned this paper a little earlier. It's a chapter in Tracy Kantrowitz, Doug Reynolds, and John Scott's new book in the SciOps Professional Practice Series, Talent Assessment, Embracing Innovation, Mitigating Risk in the Digital Age. This chapter is what called Fixing the IO Psychology Technology Interface, Avoiding IO Tech and Tech IO Conflict. It's all about how I have seen essentially in industry and through my consulting practice, how these teams don't talk to each other real well. So if you still find yourself kind of like annoyed when the tech team starts talking about, well, we got a Scrum, why aren't you Agile, like all this. If you find yourself on the wrong side of those conversations, my hope is that chapter will help you. Also, that book is phenomenal. I mean, they really put together it's an all-star cast. It's really, really good piece. The other piece here, this one down here, Landers and Marin, is one where we try to trace back why so little IO psychology theory, why so many papers that IO psychology students read in grad school do not prepare them for this world, for the world of technology. And there are some systemic issues associated with how IO psychology has historically been studied and understood that has led to the challenges we now find ourselves in. And this article, if you're curious, is about how to better navigate those issues. Overall, what I hope you will do, what I hope you take from this, is that these are tools you can use today, tonight, tomorrow, in your everyday existence, in your work, and they are things that we need to customize and need to understand in the use, in the practice of IO psychology, or else we are going to get railroaded by all of the tech people who don't care about the standards of rigor that we do. Everything that we bring to this situation, our focus on constructs, our focus on people, on humans, on the experience of work, of the fundamental challenges that people have in organizations, none of that is present in this culture that is taking charge of this. They're interested in making scalable products that make companies a lot of money. And that's, That's a part of what we care about, but that's not the main thing. And that's missing. What we bring is missing from that perspective that they're coming from. So we have to be in these conversations. We have to be working with technologists to solve these kinds of problems. I hope you will take that charge. So yeah, that is it. Thank you so much.